called
Yeah.
that.
Okay.
Okay, so okay, that is memory chunking. Let me, yep. So what I want to say, to be able to build memory chunks that last in your long-term memory, you have to do two things. You have to practice retrieval. Okay, so
Okay.
practicing retrieval, one of that we do it in the class, which means that I will always ask you to recall the information that I mentioned to you. So that is part of the learning process, not testing you. And you have
Okay.
also to do something called space repetition. So space repetition
Okay.
means that not in one day you repeat the information that you studied 3 or 4 times just to keep it. No. So every 2 or 3 days, you took some information, you want to keep it in the long-term memory. So you have to always revise it. By revising
Yeah.
it, you are
Yeah.
telling the brain that this information is actually important to you. So he will start to build strong connections around this information in the brain. So now have a look at this. Can you recognize what is that?
Right. The book index. Yeah.
Exactly. What is
Yeah.
the purpose of using a book index?
So that you can find where the information is on certain
Perfect.
things.
Easily, right?
Yeah. Yeah.
Okay. So I will tell you in the brain where is our memory index. So the memory index actually lie in the hippocampus. Okay. So the hippocampus actually there is two parts of it here in the brain.
Right.
And when you listen to me at the moment, all the information is actually start to be gathering here in this area in the brain.
Okay.
And the one who orchestrate passing the information from the short-term memory in the brain, which is here, to the long-term memory that is covered all around this area, is actually the hippocampus. So this hippocampus act like index of the book. So it acts like indexing the information into your brain. Okay.
Yeah.
But why?
Yeah.
I mean, why as a student of computer science who want to study programming need to care about how the brain works? Well, okay, there is only one information that I want to pass to you. Typically, every 10 to 15 minutes, the hippocampus is actually is get saturated with information. So every 10 to 15 minutes, it's better to take 1 or 2 minutes of silence, either from the teacher perspective, if I am teaching you, every 10 to 15 minutes, then I will take 1 or 2 minutes of silence. That help your hippocampus internally to be able to actually orchestrate and pass all the information that need to be stored in the long-term memory. If I don't do that, what will happen? So the hippocampus is actually like a cup. If you keep pouring information, consider it like a water, so the water will flow up and it will fall and you will never get use of it. So to be able to get use of that, I have to actually take 1 or 2 minutes of silence. So did you get what I mean here?
Yeah. Yeah.
Okay, great. So now consider that, please. What you see here is a picture of the brain and how the information is actually. Let me try to remove that so that we remove any. Okay. So okay. You see, compare this picture to that picture. You will see more connections between different information in the brain.
Yeah.
I need to tell you two information. We don't need to study the brain and how it works. Again, it's not our business here. But our business, as a programmer specifically, uh, programming consume a lot of energy from the brain. We have to keep our brain healthy as much as we can to be able to keep doing programming for a long time in our life. So now listen here. I would like to tell you that the brain actually benefit from all the information that you study. So reading books that is even not related to programming actually helps your brain in general and help to improve your how you think. Okay, So don't say because, oh, I'm studying programming, then I would only focus on programming books. No, general knowledge also helps the brain in many ways. Okay, so that's one. Second thing is sleeping well is actually an excellent way to consolidate and build links between the information. When you build links between the information, you are able to do a good brainstorming. You're able to improve the ability of your brain to find solution for problems. So that happen only when you sleep well. If you don't sleep well, that will not work well. Okay? Did I make sense here?
Yeah.
Did you get me?
Yeah.
Okay, perfect. Okay, so there is the last thing I'm going to talk here about the brain is actually two things. Your brain works in two modes. Okay, something called diffuse mode, and another one is called focus mode. Focus mode, now at the moment, you are now in the focus mode because you are listening to me, trying to grab what I'm trying to tell you. But there is another mode that you're able to activate, and this is very important. Why? Because that diffuse mode or diffuse thinking is a mode that you're able to put your brain in, and that help you to solve problems. It help you in brainstorming. It help you to become creative. If you have a problem, if you want to find a solution for, you have to activate the diffuse mode. But how to activate that mode? Okay, so see, one of the things that can help you activate the diffuse mode is to make your brain in a relaxed mode. If you take a shower, not thinking about anything, not putting inside your brain that you are thinking about anything, just enjoying the moment under the shower, you are putting your brain under the diffuse mode. If you close your eye and try to relax without thinking about anything at all, this is putting your brain in a diffuse mode. And if you sit or walk beside the sea thinking about nothing, also this activate the diffuse mode. So if you have a problem that you cannot find a solution for, don't keep yourself stuck in the problem, and you will have to face and deal with that in programming. Always you will face a problem that you need to solve. So how you do that? Not, oh, I need to stay hours until I manage to solve a problem. No, that's not the smart way. The smart way is to make use of the diffuse mode in the brain, take a rest, go for a walk, drink some tea, some coffee, enjoy your time, take a shower. This will help you and improve your abilities to find a solution for problems. Okay, did that make sense?
Yeah.
Okay, do you know now how to activate the diffuse mode?
Yeah.
Can you tell me how?
Just by relaxing, not stressing your brain.
Okay, that you make it in a short words, but excellent. Good, that's good. Okay, so let me go then. Okay, so typically in our class, we have class resources after we finish every class, and that class resources become available to you after 36 hours, and that is done by an assistant. So typically all the class recording is recorded in a page that is actually created specifically for every student. So typically I will pass to you a link that is specifically for all your classes that you take with me. It's a section for videos, so you will find different parts of the video record of the class recording. Okay, that's one thing.
Okay,
and typically here also, let me see here. Typically also you will find that there is a slides with every class. So every slide that I use inside the class, I will be passing it to you, and I will put links for it inside the page that is specifically designed for you, and you are able to download that slides actually. So I pass you the link, you click the link, you're able to go to every slide and every image that I use, or every even whiteboard that I use during the teaching. All the class recording is uploaded to YouTube, and also the links is provided to you on the class page, so you're able to reference it at any time. And then most of the programming that we are going to do, we do it online. so that I'm able to share the code easily with you, and you are also able to pass me the homework easily. So if you have to register on that website, Repellite, so typically it's used by most of the teachers, even in university. So that we are able to use it for Python, for Java, and for many other languages. Okay, it is a free account that you are able to use it. So okay, perfect. All the class codes also will be passed to you. And but actually, I don't pass you individual files. I pass you the link, and then the link from the page that I gave to you. Then you're able to reach the code for every class. Now let's have a look at some technical aspects. So in technical wise, actually, there is many information that you can get specialized in. So there is artificial intelligence, and that allow you to deal with information and images. So there is many libraries, and specifically with Python, you are able to use Python to deal with images and videos. So you are able to create some kind of coding that is able to analyze videos and get out certain facial faces, or even do some effects on the video itself. So maybe, as you can see, certain videos, they hide the identity of the speaker. And that actually, this specific, so this is the face of the person, and we was able to actually blur his face. So we use artificial intelligence to be able to recognize parts of his face, and we are able to use Python code. Actually, that part is actually done by a Python code. So we use a Python code to analyze the video and be able to blur center parts. So we are able to make that as large as to cover all the face, or even to only cover the eyes. If you look into deep details here, you will find there is blue actually dots on the face itself. So that blue dots is actually part of the facial recognition. So AI with Python are able to recognize where is the nose, where is the eyes, where is the eyebrow, where is the mouth itself, where is the chin. So based on that, we are even able to get out or even extract certain parts of the face. Like you see here, we managed just to cut some part of the right eye. Okay, so that is all possible using AI and Python. So again, we use a library called OpenCV to be able to do this facial detection. And there is a lot of medical usage of AI and OpenCV and Python here, because for people who have accidents, if we train our AI models, we are able to actually do a facial recognition. So you see the face here. This is the face of the person. We train it with different images in different situations. And if you see his face here, actually he have a problems by hitting the face or some kind of accident that actually makes face not recognizable. So by training the AI models, we are able to actually use it in medical to be able to recognize that who is the identity of that person. Okay, so that is all possible usage. And also AI with Python are able to recognize things like cars, traffic lights. So what is the usage of what do you think we can use this kind of maybe checking or understanding how many cars here in the scene here? What do you think we can use it for?
Maybe you can use it for like investigation if there's
counting the cars. In certain places on the roads in Malaysia, you will find the people sometimes sitting counting how many cars pass through this road. It's part of the analysis to be able to understand if they need to put more traffic lights or less traffic lights, or how they improve the flow of the traffic here. Yes. Okay. So also, if you look here, that is part of a program that was done to help blind people. So a blind person can wear a smart glass, and this smart glass are able to, if using Python and OpenCV, they are able to recognize, oh, this is a chair, this is a table, and this is maybe a laptop. So it's able to read and tell the blind person, oh, what the camera is actually seeing in front. Okay, so that also have medical reasons. Now let's have a look at project. So that is project that I personally worked with, because before I was a teacher, I'm also doing engineering projects. So now listen to here.
Okay.
So one of the things that actually I have personally done with robot arms is using vision system with robot arms. So automation in general and using robotics, actually it is quite blind, and it cannot really take a smart decision unless you equip it with vision. So when you equip any equipment with vision, then you add to its ability to actually take a smart decisions. So it will not do a lot of mistakes. In this case here, this was if you heard about RFID, did you hear before about that? So that is an RFID that is used for creating cards and passports, actually. Okay, so this is the chip that is responsible or is storing information inside the RFID itself, and this is the wires that need to be bonded to the chip. To be able to bond that 0.8 mm wire using a 1.2 bonding tip. So the bonding tip is something, of course, when you study robotics, so somehow you need to understand about some part of electrical and mechanical things. So if you have a small wire like that, and you have a bonding tip that is quite also not so big, so you really need to be, so this is 1.2 mm, that's quite small bonding tip. You need to make sure that you hit the wire almost in the middle. So you cannot do this without a camera system. You need a camera system to look and recognize. So that is part of analyzing. The camera system actually analyze where is exactly the location of the wire. So if the wire is moved to the right or the left, it initiate or give instruction to the robot arm to shift its going down position or the bonding position to the right or to the left based on the movement of the wire. So that is kind of a smart system. Okay, so now let us move to something here. That is actually the machine that produced the German passport, and that is that was done in the facilities in North Malaysia. So that is some of the joint venture with German companies that produce that machinery in Malaysia, in the north. So this is the passport, how it looks like. This is using RFID. This is the chip that stores the information inside it. And of course, that is a picture of installing that machinery in Germany. But of course, that machine was designed and built, and the software was written inside Malaysia, in the north. So this is how the machinery looks like. And and I believe if you, like your mother told me that you're going to study robotics, so that is that can be something interesting for you to know. Now let me go here. So I personally help people in the university level, although I have students who are in the secondary schools here, but I also help people study Java for pre-university who's going to study computer science. I help master students who are learning Python in the Colorado School of Mines, that's in US. Undergraduate student who are learning Python for their cybersecurity. This is in Mason University in also US. Okay, so now let us have a look. Do you know what is the meaning a low-level language?
Just more simple instructions, is it?
Yes, it is a low-level language. It's not simple instructions. Low-level language is a language that is written for a specific processor. Do you recognize this as a processor?
Yeah. Intel and Ryzen.
Yeah. Excellent. So a low-level language actually is very hard to write. Sometimes I personally have written some kind of low-level language in my career when dealing with machinery, but not all the time you have to do that. So that is, I believe, maybe 15% of your time might be you need to write low-level language. Let me give you an example of how a low-level language looks like, and then we can resume the details. So a low-level language, an example of it can be something called assembly. Have you seen any assembly code before?
I can't remember.
Okay, no problem. Let me confirm first about that here. Okay, do you recognize anything in the image?
Oh, yeah.
Okay, tell me what you recognize here.
I've seen this, before, the accumulator and then the CIR.
Okay,
Then you will
perfect.
add the numbers when
Okay,
you go down
good.
the code. Yeah.
Okay, excellent. So do you recognize what is that?
Yeah, that's a motherboard.
This is a motherboard, and this is
Yeah.
a CPU, or
Yeah.
perfect. Okay, and this
Yeah.
is how the RAM looks like. Did you study how the RAM looks like from inside, or how it
Yeah,
works?
I've seen this. Yeah.
Okay.
We didn't really study how it works that well, but yeah.
Okay, so the RAM inside it, actually, to be able to store information, we have two portions that we need to deal with. One part is actually the addresses in the RAM, and another part is the data. So this is the portion where we store the data, and this is the address. Okay, so
Yeah.
you know that every home have a number, right?
Yeah.
Okay, so we are able to recognize any home in Malaysia by having a street name and a number for the house. Am I right?
Yeah.
So we need to do that with the RAM. So the numbering in the RAM, so let's say for easy understanding, so we say 0, 1, 2, 3, 4, and so on. Okay?
Yeah.
So
Yeah.
we will be always addressing, I want to get information from address 0, or I want to store information from address 2, and so on. So now let me give you just a simple example of if we want to compare a high-level language to a low-level language. Now look at this kind of code here. Did you see that code? Do you understand what this line is able to do?
You can add, it can do like addition, multiplication for you.
Okay, this
Python can,
specifically add these two numbers, 5 plus 2,
correct.
and store the results here, right? Does this make sense to you?
Yeah.
Okay. So if you look at the RAM from inside here, but we are looking from the high level language perspective, huh? So we have a place in the memory that we call it sum. Do you know what the meaning of variable?
Yeah.
What is a variable?
Variable is like it's like change, like a thing, an item that can change, or an aspect that can change.
Okay, excellent. In programming language, we use the term variable a lot. We use that term to be able to actually store information. So in high level language, we don't use commonly memory addresses. We mark memory addresses by names that we are able as a human to recognize it and memorize it. So when I tell you I am storing the addition, the result of the addition 5 plus 2 inside sum, and we call that sum a variable. Actually, in reality, under the hood, this sum is actually a place in the memory, in the RAM, that is storing the result of the addition. Okay, so that sum can actually be maybe the position number 10 in the memory, but we don't need to care where exactly is this address, because this is a high level language that we're dealing with. But now, look, if we would like to consider something with assembly language, so have a look here. If we are talking about assembly, so the 3 lines of code here is actually equivalent to 1 line of code in Python. So have a look. This is called LDA8. So can you guess what is that doing?
Is
No
it
idea.
like the base number? So like instead of for like Python, you can just put sum equals 5 plus 2. Maybe for the low level languages, you have to put 8, then add 9. So you have to put the number 8 in a separate line of code first.
Okay, so now let me try to clarify that to you.
Yeah.
Okay,
Yeah.
perfect. Okay. So actually in assembly language and low level language, we have to deal with memory addresses. So when I say load 8, I am telling the CPU, go to the position 8 or the address 8 inside the RAM and load
Okay.
the content of the RAM from address 8 and put it inside the accumulator inside the CPU. You can still remember the accumulator, right?
Right.
This is the
Yeah.
CPU and this is the accumulator, ACC, and we load 5 inside it. Okay.
Yeah.
So and add 9 is telling go to the memory address 9 and get its content and add it to the value stored in the accumulator. So this line will add 2 to 5. And then STA10 is actually telling get the result of the addition and store it in the memory address 10. So it will store 7 here inside. So can now you see how difficult it is when you are writing an assembly code just to add 2 numbers. It is here more understandable. But now by having a look, first, you never know what is the content of the address 8 or even what is the content in address 9. You just try to actually write addresses, and you sometimes you even cannot see the data itself. So actually, on the long run, if you have 1,000 line of code, and maybe if you leave it without comments and you try to revise it after 1 or 2 weeks, you will take some time to be able to recall what is actually this line is doing. Okay, it's not so easy to really grab its functionality by just looking at it if we compare it to Python, for example. Okay, so but the point here at a low level language can actually translate to something called machine code line by line. So a machine code, or as you know, that actually the computer from inside is a piece of metal. It doesn't understand anything. So it's like electronic circuit inside, right? So it's only able to understand ones and zeros. Only 1 and 0. You know that, right? It's binary, right?
Yeah.
Okay.
Yeah.
So this line of code, LDA 8, are able to translate to a machine code in just one by one. So one line of assembly language are able to translate to that line of code. But again, if you previously in 60 years ago, people have to write programs in machine code. Can you see how difficult is that? If you look at this kind of lines, if you have 100 lines of those, you cannot really tell which one is doing what. It's very hard, right?
Yeah.
That's why after the machine code, the second improvement is that they actually created assembly language. So actually, the first programming language was the machine code. But they recognize that if they want to improve and write longer codes, it's very hard to do it in machine code. So that's why they create assembly language. And after assembly language come languages like Python and Java and so on. Okay, so this is the recent languages.
Yeah.
Okay. So just in short, or in summary, what I want to tell you that in certain times, if you want to do a full control of the hardware, you have to write an assembly language. I never needed to write any machine code when I was trying to actually do some programming, and even programming for machines. I never needed to actually write machine code. But at certain times, I needed to write assembly language, and I integrated with C++. So that is for low level. If I want to do a faster code that execute very fast, because as you know, if you want to control a machine and you want to improve the output of the machine, you have to execute everything in milliseconds. Okay.
Yeah.
And you have to care, because so every time you are not able to make your machine productive, this result in losses to the factory you are producing the machine for, right? Okay, so this is in summary that what I wanted to actually tell you. But let me just tell you a few things in the few minutes that we still got here. We have a few things that we are able to use to translate any programming code that we write to the machine code, because the one that get executed in reality in the machine under the hood is a machine code. If you write assembly, you still need a translator to be able to translate that lines of code into a machine code. We use here something called assembler. In short, that is a form of translation. You translate assembly language, which is readable to your eyes, to a machine code that makes sense to the machine or to computer inside. But what about Python? Can we use also assembler? Actually, no. Every language needs its own translator. Okay, so if we look, if we talk about Python, for example, you need something called interpreter. Okay, so that acts as a translator. It takes a Python file, it takes something readable, and translate it to ones and zeros that is understood by the machine. Okay, does this make sense? Okay, so there is one more remaining type of translators that I would like to tell you about, which is called compiler. So this compiler actually works with C++ languages. So Java have its own translator, C++ have its own translator, Python have its own translator. Okay, and same goes with assembly language. Okay, so typically if you understand one programming language, then you will be able to go faster in learning other languages. So the first step is the most difficult step. You take the basics in one language and then you expand that knowledge to other languages. So Python in general is actually smart or being used mostly for data analysis, for AI application, for mostly cybersecurity applications. Is also written in Python. Java have a different type of applications. It doesn't, mostly it is enterprise applications, okay, or even desktop applications. It's not used mostly in cybersecurity or even in robotics in general. So they use different kind of languages if you want to control robotics. Okay, so mostly languages like robotics, like C++ is used with machines and robotics. C# is used. VB.NET is also used in robotics. This is three popular languages that I have seen many factories actually use them. Okay, as I told you, Python goes with cybersecurity and and AI. Okay, and vision system and so on. So now tell me, did you understand anything from what I explained to you today?
Yeah.
Did you manage to grab any information from what I explained to you? What is your level of understanding? Can you say that you understood 50% of what I said, or 60, or 70, or 80?
About most of it, I'd say 80%, 90% of what you said I could understand.
Okay. Do you know what is an algorithm is?
Ooh. Algorithm is like a method where the computers get information, right? Like how they like a blueprint for computers, kind of.
Yes. Okay. So algorithms actually not only for computers, it's actually in general. So if we talk about a recipe to make a pancake, that is a kind of algorithm actually. So an algorithm is algorithmic thinking is a way to produce instructions to produce something. And if you give that instructions to anybody, he will come to the exact same result. So a flow chart here, even though it is mostly used with programming and computer programs, but we are also able to use it to describe the recipe for making a pancake. So he's telling, okay, you start, you place 100 grams of flour in a bowl, and then crack 2 eggs in the bowl, and then you add 300 milliliter of milk, and then you mix together until you reach certain fixture of all this mix, and so on. So that is in summary. So this is this can be represented if you look at IKEA manuals. This is kind of recipes or algorithmic thinking to be able to produce that kind of manuals that can make you fix a chair that everybody who follows that recipe or flowchart or algorithmic thinking can actually reach to the same result. So I would stop at the moment and see how it goes with you. I hope you enjoyed the class and hope to see you. Okay, take care.
Okay.
See you
Yeah,
again.
you
Bye
too.
bye.
Okay. Bye bye.